Ladies and gentlemen, welcome to my job shop. My name is Keith and I'm your host. Today we have an aluminum impeller. Almost looks like a turbine type of impeller. It's got quite a few flutes, minus one that has separated from here. This is the second time this has come into our shop, but it's not because of our last repair. Better than 3 years ago, we replaced this flute right here. And I'm looking at the edges here because I'm trying to think of how I went about shaping this piece. And I look at the edges of it, and you look at it real close, and they're sheared. And the more I think about it, this actually is probably way longer than 3 years ago, because I believe I had my foot brake shear and roller at that time, and that was some time ago. Anyhow, I made it out of 6061, and I made it 3 pieces, and I welded it together. It was a full penetration weld here and here. Let me zoom you in so you got a better picture of that. A little better when you're zoomed in. You can see what I'm talking about. This is welded in here, but it was also full. It was a full weld on the outside, and then I took and kind of smoothed that. These original ones are done with material that they could put in a brake and bend this leg right here. The same up here at the top. This is the one that popped out of this location here. So this was in here, basically something like that. This hit, I don't know if it was something that they sucked in and it hit it, or when this flew out of here, and did it hit something on its way into the rest of the ducting. Okay, my first step is to go ahead and remove these rivets, and just like I did on this one here that I replaced some time ago, I'll reach in behind here and remove the mushroom section here, and then I'll drive them out that way, and that'll keep this remaining piece here pretty well flat and intact. Then I'll take this piece and this piece here that's bent, and I'm going to straighten and flatten it out. I'll create a CAD drawing with my Fusion 360, and then we'll put it into the WAM and create a file that will cut the 3 pieces that we're going to fabricate this missing flute here in the Wazer. We're going to let the Wazer do the finished holes and everything. This is gonna be cut it, weld it, and rivet it. All right, let's get going. Okay, in case you were wondering, I found my bag of miscellaneous rivets, and I have some in here. We'll have to modify the shank a little bit, but we have enough to go ahead and duplicate the same rivet as before. That was sweet. All right. When I'm removing sections like this, I like to use my rotary burrs, and this is kind of a ball end mill, or a ball shaped burr, and I add a little bit of Alumatap. It just helps it from getting sticky and gummy. And then I rinse it once in a while when I start seeing it starting to fail or clog up. I'll add more to it and it clears right out again. Because I just want to work on that area and get most of that down. Bring it down almost all the way, and then I'll let the little sanding disc take the rest of it off of there. I'm just trying not to damage or take any of the base metal from the backup disc here, or the backing plate of the impeller itself. That material doesn't clog that much. I grabbed a few of these down in Florida when Lisa and I went down there for February, down at Fort Meade's event, and one of the vendors there had quite a few of them, and I grabbed a handful of them to try them out, and I kind of really like them for the 90-degree hit, air motor I got here. Really makes short time removal. Okay, minimum damage to that, and now we're going to take a punch and we're going to drive each one of those out of there. There we go. All right, we'll get those sanded, punched out of that piece there, straighten that piece out, and we'll go ahead and put this in the press and we'll straighten that piece out. All right, between cranking it in the mill vise and taking a rawhide hammer, we beat the flute right back into shape here, and this is kind of what it looks like when it's together. All right, this goes in here like this, and this sits in here like this, and then this is pulled up here, and that's kind of tweaked right there. So we're going to go ahead and straighten out this area here first, and then we'll go and we'll draw out our pieces. Now, I really like my Bessie clamps a lot for kind of tweaking out some of these things like this, because they give you a nice big flat footprint right there. I'm just going to kind of squeeze that. And I really like these a lot because they let you get down in here. Kind of tweaking it right back into shape. Okay, the rest of that there we're going to hammer out with a couple ball peens. That's short stroke in it. That fits pretty good right in there. Okay, let's fab our new piece here. Okay, I press the big piece flat, and it did create a crack or a split there, but it folded it open, and the other piece is laying flat as well. I scanned them into the computer, and then I took and created a CAD drawing from that scan, and then I went ahead and transferred it over to the WAM program and created the file. Okay, that's going to take about 10.3 pounds of grit here, and it's going to be about 31 minutes to cut this out. But if it's cutting it out at 100% finish, ready to weld and install, that's not too bad to actually have something that ready to go for a weld project and then get it riveted in. All right, we got everything on our SD card. Let's head to the Wazer. Okay, we bolt our sheet down here. We had a cutout in here. All right, this was our cutout that we cut out of this piece here. And of course, we made a mistake of just putting it willy-nilly wherever we wanted, and it cut it out in the middle. This piece did cut over here somewhere. We rotated this piece around, and we're basically going to take our piece out of the corner right over here. All right, so we're at the point where we need to set the nozzle height. Okay, we like that. Check out extents will be okay. So right now we're kind of checking it out. This is the first time I've actually done that to show you the outside window of where it's going to cut. Okay, I'm happy with that. So we're going to cut material, and that's as simple as press start. All right, we're gonna let that cut out and we'll come back when it's done. Okay, we're like last half inch right here. Okay, let's pop her up and see what we got here. I just wanted to try see how just a regular throwaway paintbrush works on just kind of clearing off the top of your project here. That works out pretty good. I tried hosing it, but then you build up on the water there. Okay, my tabs were a little light, but the parts pop out. All right, let's go rinse them off in the sink and go over to the welding table. Get ready to put these together. Okay, this is just a piece of angle that I have in the vise here. I use these for a lot of different things, but also holding and prep so that it preps the weld area for 100% weld penetration. We're gonna weld in this length right here. We're gonna just do a couple tacks and everything, and then we can reposition these. We just got a bridge between this 1/8 inch here and this here because there's no room to actually grab the clamp in here to hold these. But that is the position we want, and then this will be welded out here on this one. All right, I got this 1/16 TIG rod here. Maybe small. I might have to go to the 1/8 inch, but I don't have anything in between. I'm not really worried about abundance on this side here because we're gonna sand this radius right here just like we did on the one we did before some time ago. Now that we got it clamped, I think I can just go ahead and angle this down like this. Whenever you're welding a corner in here, it doesn't tend to pull or distort as much as a lot of other welds. There we go. Now we can just buzz that weld across there. making sure you got end to end is 100% sealed, and then when you sand and finish it off, you're going to make sure that you don't have a stress riser area where a crack could start. That looks pretty good. All right, that'll be ready to sand. I'm going to set up on the other side. Okay, now the short end, same thing as before. Okay, let's check how it looks in here. That's going to look pretty good. That does have to go down a little bit. It's almost making the contact right there. So we're going to radius this up a little bit, and then this will have a little chance to bend, and this will have a little chance to bend in here. Awesome. That's bent down a little bit right there. So, but these welds are just kind of holding it from seating all the way in there. All right. It's a little bit fat of a weld, but that doesn't, I'll still be able to get it locked in there really well. All right, we're gonna go cool that off. We're gonna sand off the outside and we're gonna start fitting it into place. Okay, we sanded this radius here on both sides. We're leaving this full. We are gonna take and probably flatten a little bit of this out for the head of a rivet. Just a little bit, because they go in that direction, they go in that direction there. We took it, brought it over here in a virgin area, and you can see that we got the fit up exactly where it needs to be. So when we go to put it in over here, when the rivets grab a hold and tighten everything up, they'll bring this down where this needs to be. All right, because it was pushed up, remember, before I hammered it back into place. All right, now we're gonna run the reamer through and finish dressing all of these holes. They're at like 294, 295, and we're gonna ream them out for a 5/16. That's what we have as far as rivets. And then they'll be brand new, all clean holes. And then we're gonna cut these rivets off to shortness. Even though they're aluminum and they're very, very lightweight, we wanna hold the balance on this as close as we possibly can. When we replaced this, the owner of this took it to a propeller shop, they put it on a balancer, and they virtually weren't, they basically didn't need to take anything off. So the original balance was still well, and by us making the blade the way we did, exactly the same dimensions and everything, and using the comparable rivets, we're holding the same kind of weight, evenness as this was before. We're looking at the back side, and we want to take in compensation where the balance was originally, was here. All right, and then this is some drill points from the last time they balanced it, and those distances off right there and there have nothing to do with the blade that we lost last time and the one we're replacing this time. Okay, we're just reaming these out to 5/16. Okay, we're gonna go get a couple 5/16 bolts so that we can put it through, hold it in semi-place there so we can work one rivet at a time. We want to assemble the rivet, mark it to the length, and then cut and modify them. And then we're gonna set up an anvil type of situation where we can drive them home. Okay, now that we got this drawn down here, you can see that this levels out here. And we're sitting pretty here. This is mated up the same way as all these, looking good. We put in our first rivet here. We lined up the hole, we just ran the reamer through it so that we know exactly where it's at. And it looks like it has about maybe a 1/16 to draw up. And I think these are all about 1/8 of an inch proud. So I'm just going to take and set them up, and I'm going to cut them 1/8 of an inch proud here, sand the end real lightly, put them in there, and we're going to anvil each one of them down it as we go. Not everybody has an anvil, but some of us have a small press like this, and you can get a piece of steel locked in there and act like an anvil. And what we need is just a solid, good dead blow. Now we're not going to try to drive this one home yet, because we'll be driving it home when we can turn this thing around and we can actually get in there at the right angle. So I'm kind of touching here, and I'm on the outreach here, but I'm holding it with this one here, and I want to tap this one so that I can at least know that this rivet is starting to flare and starting to hold this. The closeness of the two parts are to my liking. And I'm going to go ahead and grab a ball peen hammer versus that. Okay, I'm not going to drive it 100% home, but I am going to go ahead and give it a mushroom like that. Now I can break this one loose, and we can go ahead and put one in our 4 holes here. And we're just going to work it back and forth until we get ready to drive them all home and tighten it all up. This side here sets in there. See how I can put it in here really easy. So, all right. All right, now we can pull this bolt out. And you can see we're sitting here tight. We're tight in here. You know, I had to draw a lot on that rivet right there, but that's fine. This is nice and even around here. I like that. It's really coming together nice. Here's looking in at the other side. I haven't pulled this one 100% down in here, but that's pretty damn close. It's making contact all the way in through there. You can see some of these are leaning up, but for the most part, we're holding that position. Looking good. Okay, the last two, there we go. Okay, the last two, I'm going to mushroom those over, and it'll help seat that down a little bit. All right, I don't know if this video was riveting enough for you. All right, enough rivet jokes. Well, it's pretty cool that I can scan that, put that in my computer, create the DFX file and verify it, create the transfer from Fusion 360 to WAM, and then put it on the SD card and stick it right in the Wazer and cut that thing out, holes and everything. I mean, the holes came out to the same holes that I had in here, which were 290 something. And of course, my rivets were 5/16, and I think last time I actually put in 1/4" rivets were a little bit small on this side here, but you can see that after quite a few years that I decided to let go again somewhere else. All right, I'm gonna go put this out on the in and out bench now. My customer's in a hurry. All right, a lot of things going on. If it's holding up the job, everybody's in a hurry, and you just can't go get something when you want it. You got to fix it and keep it going. This is causing the whole plant to be down without having the extraction of debris and the other stuff in the mill. All right, the Wazer, 30 minutes, 10 pounds of garnet. That's what it took. It was 30 minutes. I could go do something else, and I was glad to have something that came out of there welded, riveted right in. Till next time, get her done.